Okay, this problem looks at sketching possible graphs of the first and second derivative from the graph of the function. So this is the graph of f of x, and we're going to look at where this graph is increasing, decreasing, and changes from increasing to decreasing and vice versa, as well as where the graph is concave up and down and where it changes. And that'll tell us how to graph the first and second derivative. So I'm going to do a number line for this one. And when the function is increasing, which it's doing from negative infinity to negative 3, the first derivative would be positive. So negative 3 would be a 0. So function increasing, first derivative positive. Notice after negative 3 and all the way down to 2, or 1 rather, the first derivative is decreasing, or the function rather is decreasing. Therefore, the first derivative would be negative. At 1, the function changes from decreasing to increasing and continues to increase. So the first derivative would be positive, and it would have zeros at negative 3 and 1. Now we're going to look at the second derivative. And we're looking at the concavity. And so notice, and this one isn't as obvious, I didn't draw that very well, but from negative infinity all the way to negative 1, the graph is concave down. Therefore, the second derivative would be negative. From negative 1 all the way to 2, the graph is concave up. Therefore, the second derivative would be positive. From 2 to 3, the graph is concave down. Therefore, the second derivative would be negative. And then beyond 3 to infinity, the graph is concave up. So the second derivative would be positive. Because of our nice smooth curve, we have zeros for the second derivative at negative 1, 2, and 3. Okay, so this gives us the sign of the first and second derivative throughout its domain. So now we're going to sketch graphs. I'll move that up a little bit here. And we always want to graph the second derivative first because remember this graph, the second derivative, is the first derivative of the first derivative. And so where this second derivative is positive and negative will tell us about where this first derivative is increasing and decreasing. So we look and we see that the second derivative has a 0 at negative 1, has a 0 at 2, another 0 at 3, and we are negative, 0, positive, 0, negative, 0, positive. So negative, 0, positive, 0, negative, 0, positive. So there's the graph of our first derivative. Our second derivative. Okay, so now we're going to look at the first derivative. We'll move that up a little bit. And let's see, adjust this camera so we can get a little bit more. Okay, so now we're going to graph the first derivative. So the first derivative has zeros at negative 3 and 1. But again, the sign of this second derivative will tell us whether the first derivative is increasing or decreasing. So when the second derivative is negative, the first derivative will be decreasing. So it decreases all the way to negative 1, and the second derivative changes from negative to positive at negative 1, which means the first derivative would change from decreasing to increasing. So somewhere down here, we don't know the exact y value, we will have a relative minimum for the first derivative. So now from negative 1 to 2, the second derivative is positive, which means the first derivative would be increasing. So we're increasing all the way to 2. Here's our 0. And then from 2 to 3, the second derivative is negative. Therefore, the first derivative will decrease. And then beyond 3, second derivative positive. And so we'd probably have a 0 there. We don't know exactly. And then there again, from 3 to infinity, the second derivative is positive. Therefore, the first derivative will be increasing. So here are your possible graphs. Obviously, we know the zeros. We don't know the exact y values for some of these other points. But here are 2 possible graphs, one for the first derivative, one for the second derivative.